Right, in this video we'll be looking at geometric progressions. Okay, so say we've got the sequence 2, 4, 8, 16, 32, and so on. Hopefully you can see that we've got a common ratio. We're multiplying by 2 to get to the next term. Alright, so 2 times 2 gives us 4, 4 times 2 gives us 8, 8 times 2, 16, 16 times 2, 32. So if you've got a sequence where the terms are separated by a common ratio, we call that a geometric progression. So for the arithmetic progression, the terms were separated by a common difference. You were adding or subtracting a specific value to get to the next term. But in this case, we've got a common ratio. We are multiplying by a certain number to get to the next term. All right, so the common ratio is denoted by the letter R. And similar to arithmetic progressions, you see the letter A being used to represent the first term. Okay, so in this case our first term is 2 and our common ratio is also 2. So if you want to find the nth term for a geometric progression, you use the formula un is equal to ar to the n minus 1. So say for example we wanted to find the third term, u3. That's going to be our a is 2 multiplied by r, which is also 2, and this is being raised to the power n minus 1, so 3 minus 1, which is 2. So u3 is 2 times 2 squared, which is 2 times 4, so u3 is equal to 8. So this is the formula for nth term for a GP, and it's also in your MF19. Just like we did for arithmetic progressions as well, we can find the sum of the first n terms, and the formula for that is Sn is equal to a times 1 minus r to the n over 1 minus r. So if you wanted to find the sum of the first 4 terms, here by doing it manually we can tell that this would be 2 plus 4, 6, 6 plus 8, 14, 14 plus 16, 30. So the sum of the first 4 terms here would be a, which is 2, times 1 minus r, which is also 2, to the power n, which is 4, and this is over 1 minus our common ratio, which is 2. Alright, so the sum of the first 4 terms is going to be 2 times 1 minus 2 to the 4, that's 16, and this is over negative 1. So the sum of the first 4 terms is 2 times negative 15 over negative 1, and sum of first 4 terms is negative 30 over negative 1, which is in fact equal to 30. And now, instead of stopping here, for geometric progressions we actually have one more formula, and that's the formula for the sum to infinity. Okay, so the sum to infinity is equal to a over 1 minus r, and r must be a fraction. So this means that r must be between negative 1 and 1 for us to have a sum to infinity. So when r is between negative 1 and 1, or in other words when r is a fraction, as you continue to go along the sequence, your terms will start to get smaller and smaller because you're multiplying by a fraction, to a point where the terms are very small such that they are negligible. And so at this point where the terms are now very, very small such that they are negligible, we say that our progression has now converged. So say for example we've got our first term is 1, and then our common ratio is half. It means 1 times half we get half, times half we get a quarter, times half we get 1 over 8, times half we get 1 over 16. So I'm not going to keep doing this, but 1 over 16 is 0.025. So you can imagine what happens as we continue to multiply by half, our terms in the sequence will start to approach 0, such that these numbers are very small and are negligible, and at this point we then begin to say that our progression has converged. And if a progression converges, we say that progression has a sum to infinity, and the sum to infinity can be calculated using this formula over here. It's very straightforward to use this formula. You just need to know what your first term is, and you need to know what r is. So in this example that I have above, we said a is 1 and our common ratio is 1 over 2. So the sum to infinity there would be 1 over 1 minus 1 over 2. And so we'd get that the sum to infinity is equal to 2. Okay, so now let's apply all this information to some past paper questions. So we're given that a geometric progression is such that the third term is 1764, so u3 is equal to 1764, and the sum of the second and third terms is 3444. So u2 plus u3 is equal to 3444, and we need to find the 50th term, so we want to find u50. So using the formula for nth term, u50 is going to be ar to the n minus 1, so ar to the 49. So what this means is that we have to find a and we have to find r. So to do that, we can use the information that we have. We know that u2 plus u3 is 3444, u3 is 1764, so u2 plus 1764 is equal to 3444. So u2 is equal to, that's 3444 minus 1764, which gives us 1680. So now we've got both u3 and u2. And using these equations, we can create two equations in terms of a and r using the formula for nth term. So u3 using the formula for nth term would be ar to the power 3 minus 1. So ar squared is 1764. And u2 would just be ar is equal to 1680. So now we have two equations in terms of a and r that we can solve simultaneously. So we can make a subject of the formula here. So that's 1680 over r, and substitute this into the first equation. So 1680 over r multiplied by r squared is equal to 1764. So that's going to cancel out, and you get 1680r is 1764. Divide both sides by 1680. Let's punch that into the calculator. That's 1764 over 1680. That gives us r is 21 over 20. And so we now have our common ratio. Let's find a. A is 1680 over 21 over 20. So that gives us a is equal to, punch this into the calculator, that's 1680 over 21 over 20, and that gives us 1600. Alright, so now that we've found both r and a, we can substitute into u50. So u50 is going to be ar to the 49, so that's 1600 multiplied by 21 over 20 to the power of 49. So u50 is equal to, let's punch that into the calculator, that's 1600 times 21 over 20 to the power 49, and that gives us 17,474.1331. And if we give that correct to three significant figures, that's 17,500. And that would be our final answer. Now here we're given that the second and third terms of a GP are 10 and 8 respectively. Find the sum to infinity. So we've been given that the second term, u2, is equal to 10, and we've been given that the third term, u3 is equal to 8. Okay, so using the formula for nth term for a GP, we can write this as AR is equal to 10 and AR squared is equal to 8. So we've got two equations in terms of A and R. So let's solve those two equations simultaneously. Let's make A the subject of the formula in this first equation, that's 10 over R, and we can substitute into this second equation. So that becomes 10 over R times R squared is equal to 8. So we can cancel out the power 2 and the R, so that gives us 10R is equal to 8. So R is equal to 8 over 10, and therefore R is 4 over 5. Using this value for R, let's evaluate A. A is 10 divided by 4 over 5. So that's going to give us A is equal to, let's punch this into the calculator, 10 divided by 4 over 5. That gives us 25 over 2, which is 12.5. So now that we have both A and R, we can find the sum to infinity. The sum to infinity is equal to A over 1 minus R. So sum to infinity is equal to, our A is 12.5, and this is over 1 minus 4 over 5. Okay, so let's punch this into the calculator. That's 12.5 over 1 minus 4 over 5, and that gives us 62.5, and that's our final answer. Now let's look at this example. We're given that the first, second, and third terms of a GP are sine theta, cos theta, and 2 minus sine theta respectively, where theta radians is an acute angle. Part A says to find the value of theta. Okay, so this is a GP, and we're given that the first term is sine theta, the second term is cos theta, and the third term is 2 minus sine theta. So to find theta, we can create two equations in terms of R and theta, where R is our common ratio. So one way of finding our common ratio is to say U2 divided by U1. So the second term divided by the first term should give us our common ratio, or to say the third term divided by the second term. And so this means that R is equal to cos theta over sine theta in the first one, cos theta over sine theta, and then we get that R is equal to 2 minus sine theta over cos theta in the second one, 2 minus sine theta over cos theta. So here we've got two equations in terms of R and theta, so we can solve these two simultaneously to evaluate theta. So let's equate our two equations. We've got cos theta over sine theta is equal to 2 minus sine theta over cos theta. So we can cross multiply to get cos squared theta is equal to 2 minus sine theta sine theta. So this is cos squared theta is equal to 2 sine theta minus sine squared theta. So let's move the negative sine squared theta to the left. We end up with sine squared theta plus cos squared theta is equal to 2 sine theta. And here we can use an identity to simplify our left hand side. Sine squared theta plus cos squared theta is identical to 1. And so what this means is that 1 is equal to 2 sine theta, and so sine theta is equal to 1 over 2. Therefore, theta is arcsine of 1 over 2. And let's evaluate this. We are in radians. Arcsine of 1 over 2 gives us 1 over 6 pi. And this would be our value for theta. Let's look at part B. Using the value of theta, find the sum of the first 10 terms of the progression. Give the answer in the form b over root c minus 1, where b and c are integers to be found. So we're required to find the sum of the first 10 terms under a geometric progression. So we use the respective formula. That's a times 1 minus r to the n over 1 minus r. So this is sum of the first 10 terms. So our first term, A, is sine theta. So that's going to be sine of 1 over 6 pi, because we evaluated theta to be 1 over 6 pi, and they say to use this value of theta. So sine 1 over 6 pi gives us, that's 1 over 2. So this is 1 over 2 times 1 minus our common ratio. We can evaluate our common ratio using this expression here. We can also use this expression, it's just preference really. So R would be cos 1 over 6 pi over sine 1 over 6 pi. So we can punch this into the calculator. This is cos 1 over 6 pi divided by sine 1 over 6 pi, and that gives us root 3. So our common ratio is root 3. So this is 1 minus root 3 to the power 10, and this is all over 1 minus root 3. And they say they want their answer in the form b over root c minus 1. So we're going to have to simplify this to get to that form. So this is 1 over 2, and we've got 1 minus. Alright, so root 3 to the power 10 is the same as saying 3 to the power 1 over 2 to the power 10. Okay, and this is all over 1 minus root 3. So what this means is that our powers here are going to multiply. This half multiplies the 10, so you end up with 3 to the power 5. So this becomes 1 over 2 times 1 minus 3 to the power 5, and this is over 1 minus root 3. So let's just punch the whole numerator into the calculator, because that can be simplified to give us an exact value. That's half times 1 minus 3 to the power 5, and this gives us negative 121. So we've got negative 121 over 1 minus root 3. I think we're almost there. They want it as a root c minus 1 on the denominator. So this root 3 has to be positive. So we can just factor out a negative sign from our denominator, so that this becomes negative 121 over negative 1 plus root 3, and the negative signs can cancel out here, so that we've got 121, and I'll write root 3 first, over root 3 minus 1, and this will be the sum of the first 10 terms, and it's in the form b over root c minus 1, and that is our final answer. Alright, so that's it for this video. Make sure to go through the quiz, and I'll see you in the next one.